the Biefeld Brown capacitor aircraft. In the early decades of the 20th century, electricity was still a frontier science, full of unanswered questions and unexplored possibilities. During this period, a young American researcher named Thomas Townsend Brown began working with high-voltage electrical systems while still a student. His experiments focused on capacitors, simple devices designed to store electrical energy, but one particular observation would define his life's work. Brown noticed that when an asymmetrical capacitor was subjected to extremely high voltage, it produced a small but measurable force. The device consistently moved toward its positive electrode, even when mounted in a controlled environment. The motion appeared smooth and silent, without any visible mechanical propulsion. At first, the effect was subtle, but repeated experiments confirmed that it was reproducible. This phenomenon later became known as the Biefeld-Brown effect, named after Brown and his academic supervisor, physicist Paul Alfred Biefeld. While conventional physics attempted to explain the movement as a byproduct of ionized air particles, Brown believed the effect pointed toward something far more profound. He became convinced that strong electric fields could interact directly with gravity itself, producing a form of force that did not rely on combustion or reaction mass. Throughout the 1930s and 1940s, Brown refined his designs, gradually shifting from tabletop experiments to larger, more ambitious prototypes. He envisioned aircraft that relied not on wings or propellers, but on carefully arranged electrical fields. His designs often took the form of circular or disc-shaped platforms, with capacitors embedded around their edges to create directional thrust. As global tensions escalated during and after World War II, Brown's work quietly attracted the attention of military researchers. The promise of a silent propulsion system, one without fuel, exhaust, or moving parts, was impossible to ignore. By the early Cold War period, Brown was working under classified contracts linked to aerospace and defense research. Publicly, however, little was said about the true purpose of these experiments. During this time, several demonstrations reportedly showed that larger capacitor-based platforms could generate lift and controlled movement under specific conditions. These tests were not performed in public laboratories or academic institutions, but within restricted facilities. The results were never openly published, and no comprehensive technical reports were released to the scientific community. By the late 1950s, official interest in Brown's ideas appeared to fade. Government agencies began distancing themselves from claims of electrogravitics, and mainstream physics dismissed the concept as a misunderstanding of known electrical effects. Research papers referencing Brown's conclusions quietly disappeared from serious journals, replaced by simplified explanations that reduced the phenomenon to atmospheric ion flow. Brown himself never abandoned his interpretation. He maintained that the observable thrust was only a surface effect of a deeper interaction between electric potential and spacetime. In his view, the real applications required voltages and materials far beyond what civilian laboratories were allowed to explore. He believed his work had been deliberately reframed to avoid further investigation. As aerospace research moved toward chemical rockets and jet propulsion, the capacitor aircraft concept slipped into obscurity. No operational vehicles were ever publicly acknowledged, and no blueprints entered commercial production. Brown died in 1985, largely unknown outside small circles of alternative researchers and classified archives. Today, the Biefeld-Brown capacitor aircraft exists mostly as a historical anomaly. Simple experimental models continue to demonstrate small amounts of thrust, yet their implications remain controversial. The technology never progressed into open development, not because it was conclusively disproven, but because it was gradually removed from the public scientific conversation. Its story reflects a moment in technological history when certain ideas were quietly set aside, not erased entirely, but confined to the margins. Whether the capacitor aircraft represented a misunderstanding or a suppressed breakthrough remains unresolved, leaving it suspended between accepted science and forgotten possibility. The Philadelphian free energy converter. In the late 1920s and early 1930s, Philadelphia was one of the most active industrial and scientific centers in the United States. Electrical engineering was rapidly evolving, and private inventors often worked alongside factories, shipyards, and universities. Within this environment, An obscure but persistent idea began to circulate among independent engineers: the possibility of extracting usable energy directly from ambient electrical and electromagnetic fields. The device that would later be referred to as the Philadelphian free energy converter was not the product of a single famous inventor, but rather a collaborative concept developed through workshops, experimental labs, and patent drafts that never reached public production. Its core principle was based on resonance. Instead of generating power through combustion, rotation, or chemical reactions, the converter was designed to amplify naturally occurring electrical potentials present in the environment. Early descriptions suggest that the converter relied on layered coils, asymmetric conductors, and capacitive plates arranged in a way that allowed the system to enter a self-sustaining oscillation. Once tuned correctly, the device allegedly maintained output without an external fuel source. Power was described as stable, continuous, and scalable, suitable for lighting systems and small machinery. By the mid-1930s, experimental units were reportedly demonstrated in private settings to industrial investors and electrical engineers. These demonstrations were not public exhibitions but controlled presentations, often requiring non-disclosure agreements. Witness accounts describe devices that powered incandescent bulbs and motors while disconnected from any visible power supply. The emphasis was not on spectacle, but on quiet reliability. At the time, the electrical utility industry was consolidating rapidly. Large power grids, centralized generation, and long-distance transmission were becoming the foundation of modern infrastructure. A decentralized energy converter, capable of operating independently, represented a structural disruption rather than a technical improvement. As interest grew behind closed doors, so did resistance. Patent filings associated with similar resonance-based energy systems began encountering unusual delays. Some applications were rejected without detailed explanation, while others were quietly absorbed into restricted archives. Correspondence between inventors reveals increasing pressure to abandon claims related to self-sustaining output and to reframe their work within conventional electrical theory. During World War II, the converter concept briefly resurfaced under military interest. Portable, fuel-independent power sources were strategically valuable, especially for communications and remote installations. However, the same features that made the device attractive also raised concerns. Control, predictability, and standardization were critical during wartime production, and experimental systems that defied established engineering models were seen as liabilities. By the late 1940s, references to the Philadelphian free energy converter had largely vanished from technical circles. Laboratories associated with its development shifted focus to conventional transformer and generator research. Surviving prototypes were dismantled, repurposed, or lost. No complete technical schematics entered public record. Those who had worked on the system later described a gradual narrowing of acceptable research boundaries. Concepts involving environmental energy extraction were discouraged, labeled speculative, or classified as impractical despite successful demonstrations. Funding disappeared, and collaboration networks dissolved. In subsequent decades, fragments of the converter's design appeared indirectly in unrelated patents, stripped of their original intent. Resonant circuits, high-efficiency capacitors, and unconventional coil geometries were incorporated into mainstream electronics, while the central idea of autonomous energy production was omitted. Today, the Philadelphian free energy converter survives only through scattered notes, patent references, and personal recollections. Its disappearance was not marked by public controversy or official bans. Instead, it faded through administrative silence and strategic neglect. The story reflects a moment in technological history when certain paths were deemed incompatible with existing systems. The converter was not erased by failure, but by its potential to alter how energy itself was distributed and controlled. Its quiet removal ensured stability, while leaving behind an unanswered chapter in the development of modern power technology. The German Repulsine engine. During the final years of World War II, Germany invested heavily in experimental propulsion technologies. As conventional aviation approached its physical limits, engineers were encouraged to explore unconventional methods of lift and movement. Among the most enigmatic of these efforts was a device later referred to as the German Repulsine engine. The Repulsine was primarily associated with Austrian engineer Viktor, whose work focused on natural flow dynamics, implosion principles, and vortex motion. Unlike traditional engines that relied on explosion and outward force, Schauberger believed that nature favored inward-moving, spiraling processes. He argued that true efficiency emerged from controlled suction, compression, and rotational symmetry rather than combustion. The Repulsine engine reflected these ideas in its design. Descriptions and surviving photographs depict a compact, circular device resembling a metallic turbine with curved internal vanes arranged in a spiral configuration. The engine lacked conventional exhaust ports or fuel injection systems. Instead, it was said to manipulate air and energy internally through rapid rotational motion. According to post-war testimonies, early tests of the Repulsine produced unexpected effects. When activated, the device reportedly generated intense vibrations, pressure changes, and in some cases vertical lift. Engineers involved in the testing described a sensation of weight reduction around the apparatus. Instruments behaved erratically, and the surrounding air appeared to compress and cool rather than heat. Despite these anomalies, the Repulsine was never fully stabilized. Schauberger himself warned that the engine's operating principles were poorly understood and potentially dangerous. He insisted that the materials used were insufficient for the forces involved and that improper tuning could lead to catastrophic failure. These warnings were largely ignored as military authorities pushed for rapid results. By 1944, the project had drawn the attention of SS-controlled research divisions. Testing facilities were relocated, and access became increasingly restricted. Documentation was fragmented, and engineers were compartmentalized, each understanding only a portion of the system. This fragmentation made replication difficult and obscured the full scope of the technology. As Germany collapsed in 1945, the Repulsine engine disappeared almost entirely from official records. Some components were reportedly seized by Allied forces, while others were destroyed to prevent capture. Schauberger was taken into custody and later interrogated, though no complete technical explanation of the engine was ever recorded during these sessions. In the years that followed, Schauberger attempted to reconstruct his work under civilian conditions. Without state funding and industrial support, progress was slow. He claimed that his research had been misused and that the Repulsine was never intended as a weapon or aircraft engine, but as part of a broader energy system based on natural motion. Mainstream engineering circles dismissed the Repulsine as an unstable curiosity. Without surviving blueprints or verifiable test data, the engine was classified as an abandoned wartime experiment. Academic institutions showed little interest in pursuing implosion-based propulsion, focusing instead on jet engines and rocketry. Nevertheless, fragments of the Repulsine story persisted. Declassified reports, personal letters, and witness accounts continued to surface, each describing a device that defied conventional thermodynamics. The absence of definitive proof ensured that the Repulsine remained outside formal scientific discourse. The German Repulsine engine was not erased through public rejection or experimental failure alone. Its disappearance resulted from a convergence of secrecy, collapse, and a post-war shift toward standardized, controllable technologies. What remained was an incomplete record of an engine that challenged fundamental assumptions about motion and force. Today, the Repulsine occupies a narrow space between documented history and unresolved engineering. Its development was real, its tests were witnessed, and its disappearance was deliberate. Whether it represented a breakthrough or a dead end was never conclusively determined, leaving its true potential permanently obscured. The Tesla Marconi suppressed patents. At the turn of the 20th century, wireless communication stood at the center of a technological revolution. The world was moving away from cables and physical connections toward invisible transmissions that traveled through space itself. Two names became inseparably linked to this transformation: Nikola Tesla and Guglielmo Marconi. Public history would later simplify their relationship into a rivalry, but behind that narrative lay a complex web of patents, legal maneuvering, and strategic suppression. Nikola Tesla began developing wireless transmission systems in the 1890s. His work extended far beyond radio signals. Tesla envisioned a global system capable of transmitting not only information, but also electrical power through the Earth and the atmosphere. He filed numerous patents describing resonant circuits, tuned frequencies, and methods for transmitting energy without wires. These patents formed a coherent technological framework, unified by the concept of resonance rather than simple signal broadcasting. Marconi, working along parallel lines, focused on practical communication. His systems were simpler, optimized for telegraphy, and easier to commercialize. However, many of Marconi's early patents relied heavily on principles already described in Tesla's earlier filings. At first, the U.S. Patent Office acknowledged this overlap and rejected several of Marconi's applications in favor of Tesla's prior art. Despite this, the commercial momentum shifted rapidly. Marconi secured powerful financial backing and institutional support, particularly from industrial and military interests that prioritized communication over energy transmission. As radio proved its strategic value, pressure mounted to legitimize Marconi's claims regardless of earlier patents. In 1904, in a move that shocked many engineers of the time, the U.S. Patent Office reversed its earlier decisions and granted Marconi a key wireless patent previously denied. The ruling effectively sidelined Tesla's foundational work. No technical breakthrough justified the reversal. Instead, it reflected a changing political and economic landscape in which centralized control of communication systems was paramount. Tesla's broader vision posed a fundamental challenge. Wireless energy transmission implied decentralization. If power could be transmitted freely through natural resonance systems, it would undermine emerging utility monopolies and reshape industrial economics. Unlike radio communication, which could be licensed and regulated, energy transmission on a planetary scale resisted ownership. As legal battles continued, Tesla's financial situation deteriorated. His patents were ignored, expired, or quietly absorbed into corporate portfolios. Many of his later filings related to wireless power and resonance-based transmission were never developed commercially. Some were classified during wartime under the justification of national security. Marconi, meanwhile, became the public face of radio. His systems were standardized, militarized, and integrated into global infrastructure. The historical narrative solidified around his success, while Tesla's contributions were reframed as theoretical or impractical. By the time Tesla died in 1943, his work was largely dismissed by mainstream institutions. Following his death, Tesla's papers were seized by government authorities and reviewed by intelligence agencies. Although no immediate applications were announced, access to his unpublished research was restricted. Certain patent concepts never reappeared in public discourse, despite their relevance to emerging technologies. Decades later, in 1943, the U.S. Supreme Court quietly invalidated Marconi's key wireless patent, acknowledging that Tesla's prior work had precedence. By then, the decision carried little practical impact. The infrastructure had already been built, the companies established, and the narrative fixed. The suppression of the Tesla-Marconi patents was not a single act, but a gradual process. Legal reversals, selective recognition, and institutional silence ensured that only one technological path survived. Communication flourished. Energy transmission did not. Today, Tesla's suppressed patents remain a reminder of an alternate technological trajectory, one that emphasized resonance, natural systems, and distributed power. Their disappearance did not result from technical failure, but from incompatibility with the economic structures of the time. The story of these patents reflects how innovation is shaped not only by discovery, but by control. What endured was not necessarily what was most advanced, but what could be managed, monetized, and contained. The Montauk time manipulation device. The origins of the Montauk time manipulation device are rooted in the final phase of World War II and the technological momentum that followed it. As military research accelerated, the United States began exploring not only new weapons and communication systems, but also unconventional methods of influencing perception, space, and temporal stability. These efforts did not emerge in isolation. They were built upon classified wartime experiments that blurred the boundary between physics, psychology, and electromagnetic engineering. Montauk Point, located at the eastern tip of Long Island, was chosen for strategic and geographic reasons. The area already housed radar installations and communications equipment designed to monitor the Atlantic. Beneath the surface, additional infrastructure was constructed, expanding existing facilities into a complex research site shielded from public oversight. By the late 1950s, Montauk had become associated with experimental electromagnetic systems operating at extreme power levels. According to internal accounts, researchers sought to explore how intense fields could interact with human consciousness and physical reality simultaneously. The underlying premise was that time, perception, and matter were interconnected through resonance rather than linear causality. The device itself was described as a large electromagnetic array connected to amplifiers, vacuum tubes, and rotating field generators. At its core was a chair-like apparatus positioned within a focused energy field. When activated, the system allegedly amplified neural signals, allowing thought patterns to influence the surrounding electromagnetic environment. This interaction formed the foundation of the so-called Montauk device. Initial experiments reportedly focused on perception distortion. Subjects exposed to the field experienced altered sensory processing, disorientation, and time dilation effects. Observers noted that individuals often described moments stretching unnaturally long or collapsing into brief flashes. These effects were recorded without the use of chemical agents, relying solely on electromagnetic exposure. As the project advanced, researchers attempted to stabilize and control these distortions. Adjustments to frequency, field geometry, and power output produced increasingly pronounced results. Test logs referenced localized temporal anomalies, including discrepancies between internal clocks and external reference systems. Equipment malfunctions became common, with electronic devices desynchronizing or failing entirely during high-intensity trials. By the 1960s, the project had moved beyond passive observation. The goal shifted toward intentional temporal manipulation. Reports describe attempts to project consciousness into non-local timeframes, effectively accessing information beyond the present moment. These experiments were highly classified, and documentation was fragmented to prevent any single individual from understanding the entire system. The instability of the device soon became evident. Prolonged activation resulted in severe psychological strain on test subjects and operators alike. Personnel turnover increased, and access restrictions tightened. Several researchers reportedly resigned, citing ethical concerns and unpredictable outcomes. Despite these issues, the project continued into the early 1970s. Military interest persisted due to the perceived strategic advantage of temporal intelligence and psychological influence. However, control remained elusive. The device exhibited nonlinear behavior, responding inconsistently even under identical conditions. This lack of reliability rendered it unsuitable for deployment or replication. By the mid-1970s, the Montauk project was abruptly terminated. Power systems were dismantled, sensitive equipment removed, and sections of the facility sealed. Official explanations framed the closure as a budgetary decision, though internal sources suggested that containment, not cost, was the primary concern. Following its shutdown, Montauk entered a period of enforced silence. Records were classified or destroyed, and personnel were reassigned under non-disclosure agreements. Public knowledge of the facility was reduced to its visible radar structures, while its deeper function faded from official history. The Montauk time manipulation device was never acknowledged in academic literature. No peer-reviewed papers, technical schematics, or experimental data were released. Its existence survived only through indirect testimony, partial documents, and the physical remains of the site itself. Unlike many abandoned technologies, Montauk was not forgotten due to failure alone. It was abandoned because it operated beyond predictable parameters. The risks were not mechanical but systemic. The device challenged assumptions about time as a fixed dimension, introducing instability where certainty was required. Today, Montauk stands as a symbol of a research path deliberately closed. Its legacy is not defined by what it achieved, but by what was deemed too uncertain to pursue further. The technology was not disproven. It was removed from development, leaving behind an unresolved chapter in the history of experimental science. The Nazi Levitation platform. During the final phase of the Third Reich, Germany's military research structure became increasingly fragmented and secretive. As conventional weapons failed to reverse the course of the war, resources were redirected toward experimental technologies that promised decisive advantages. Among these projects was a lesser-known initiative focused on gravity manipulation, later referred to as the Nazi Levitation platform. Unlike large-scale aircraft programs, the Levitation platform was designed as a foundational experiment rather than a finished vehicle. Its purpose was not transportation, but proof of principle. Engineers sought to determine whether controlled electromagnetic and rotational systems could reduce or neutralize gravitational mass under specific conditions. The platform itself was described as a circular or polygonal structure, elevated slightly above the ground and supported by non-magnetic mounts. At its core were rotating assemblies and high-energy field generators arranged symmetrically. These components were powered by advanced electrical systems capable of producing intense, rapidly fluctuating fields. According to post-war testimonies from engineers and technicians, early tests produced measurable anomalies. When activated, the platform reportedly exhibited partial weight reduction. Instruments placed on the structure registered lower effective mass, while vibration patterns indicated internal stress unrelated to mechanical motion. The surrounding air displayed unusual pressure behavior, becoming denser and cooler near the platform's surface. The operating principle was based on resonance and rotation rather than thrust. By synchronizing electromagnetic oscillations with mechanical spin, researchers attempted to interfere with the coupling between mass and spacetime. This approach aligned with fringe theoretical work circulating within classified research divisions, though it remained outside accepted physics. The project advanced under SS oversight, which prioritized secrecy over stability. Documentation was deliberately compartmentalized, ensuring no single team possessed full knowledge of the system. This structure accelerated experimentation but limited long-term refinement. As a result, the platform remained unpredictable. Several test cycles reportedly ended abruptly due to structural stress or power overloads. While no confirmed catastrophic failures were recorded, the system demonstrated behavior that operators struggled to control. Field strength fluctuations occurred without command input, suggesting nonlinear feedback within the device. Despite these issues, interest persisted. Levitation, even in a limited form, offered implications for propulsion, materials handling, and weapons deployment. However, the platform never progressed beyond stationary testing. Mobility was considered premature given the instability observed during fixed trials. As Allied forces advanced in 1945, the Levitation platform project was classified as a priority for destruction. Facilities housing the experiments were evacuated, and remaining equipment was either dismantled or rendered inoperable. Engineers were reassigned, captured, or disappeared amid the collapse. Following the war, fragments of information surfaced through interrogations and intelligence reports. Allied analysts noted references to weight reduction experiments but found no complete schematics or functional devices. Without physical evidence, the platform was categorized as an abandoned concept rather than an operational breakthrough. In the post-war scientific environment, gravity manipulation became associated with speculative or discredited research. The lack of surviving hardware ensured the Levitation platform remained excluded from formal study. Its principles conflicted with the emerging consensus around rocketry and jet propulsion. The Nazi Levitation platform did not vanish because it failed to produce results. It vanished because it existed at the intersection of instability, secrecy, and defeat. Its development was interrupted before its limitations or potential could be fully understood. Today, the platform remains a silent entry in the record of forbidden inventions. Its existence is supported by consistent testimonies rather than conclusive data. The technology was not disproven, but abandoned at a moment when history left no room for uncertainty. The Tibetan acoustic levitation method. High in the Tibetan plateau, isolated from the technological centers of the modern world, ancient monasteries preserved traditions that blended observation, ritual, and disciplined experimentation. Among these traditions was a method described in fragmented historical accounts as a means of lifting heavy stone objects using sound alone. This practice, later referred to as the Tibetan acoustic levitation method, was never formally documented in scientific terms, yet its consistent appearance in eyewitness reports suggests a structured and deliberate technique. Accounts of the method began reaching Western researchers in the early 20th century through explorers, missionaries, and engineers stationed in the region. These observers described monastic ceremonies in which large stone blocks were positioned within carefully arranged acoustic environments. The process relied not on brute force, but on precise coordination of sound frequencies, rhythm, and spatial alignment. The method employed long ceremonial horns, drums, and chanting monks positioned in geometric patterns. Each participant maintained strict timing and tonal consistency. The sound waves produced were not random or symbolic. They were controlled, sustained, and directed. Observers noted that the tones created a deep resonance that seemed to saturate the air around the object. At the center of the arrangement stood the stone to be lifted. According to reports, once the acoustic system reached a specific harmonic state, the stone began to vibrate subtly. These vibrations increased gradually until the object appeared to lose contact with the ground. In some cases, the stone reportedly rose several feet into the air and moved laterally before being lowered onto a prepared surface. Local explanations framed the phenomenon as a natural interaction between matter and vibration. Monks emphasized balance, timing, and resonance rather than force. The method required extended preparation, precise placement, and strict discipline. It was not presented as a spectacle, but as a practical technique used during construction and ceremonial relocation of materials. Western engineers who attempted to analyze the phenomenon struggled to reproduce it. Without precise measurements of frequency, amplitude, and spatial configuration, the method remained elusive. Sound-based levitation experiments conducted later in laboratories achieved limited success with small objects, but failed to replicate the scale described in Tibetan accounts. During the mid-20th century, geopolitical shifts led to the closure of many monasteries and the dispersal of their practitioners. Oral traditions were interrupted, and the acoustic method was no longer openly demonstrated. The absence of written documentation ensured that critical knowledge was lost as custodians of the practice disappeared. Scientific institutions showed limited interest in pursuing the subject. Acoustic levitation conflicted with established engineering priorities and offered no immediate industrial application. Without reproducible data, the method was categorized as anecdotal and excluded from serious study. By the late 20th century, the Tibetan acoustic levitation method existed primarily in archived testimonies and secondary reports. Attempts to revisit the phenomenon were constrained by cultural disruption and the lack of surviving practitioners willing or able to demonstrate the technique. The method was not erased through prohibition or direct suppression. It faded due to disconnection. As modern construction methods replaced traditional practices, the acoustic technique became unnecessary. Without demand or institutional support, it quietly vanished. What remains is a historical record of a technology rooted in precision rather than machinery. The Tibetan acoustic levitation method represents a path of development that prioritized harmony and control over power and speed. Its disappearance reflects how technologies can be lost not through failure, but through cultural disruption and neglect. Today, the method stands as an example of an approach to physics that operated outside formal equations, relying instead on disciplined repetition and experiential knowledge. Its principles were never disproven, only left unexplored as history moved in a different direction. The Soviet Weather Control Generator. During the height of the Cold War, when ideology divided the planet into opposing hemispheres of belief, the Soviet Union turned its attention upward, toward the sky itself. Weather, once considered a neutral force of nature, began to be viewed as a variable that could be influenced, nudged, and possibly controlled. In an era obsessed with strategic advantage, even clouds became potential assets. Soviet meteorologists and military planners believed that weather was not merely chaotic but responsive. Beneath the randomness of storms and winds, they suspected patterns, hidden levers that, if pulled correctly, could reshape atmospheric behavior. From this belief emerged a classified initiative known informally among researchers as the Soviet Weather Control Generator. Unlike simple cloud seeding programs already explored by other nations, this project aimed for something far more ambitious. The goal was not to produce rain in a drought-stricken region, but to influence large-scale atmospheric systems. Storm paths, pressure fronts, temperature gradients. The generator was designed to interact with the ionosphere and upper atmospheric layers, where weather systems were thought to be most sensitive to disturbance. The facility itself was built far from population centers, hidden within a restricted scientific zone in Central Asia. From the outside, it appeared unremarkable. Low concrete structures, transmission towers, and a wide field of antenna arrays stretching across the steppe. Inside, however, the machinery reflected an unusual fusion of disciplines: meteorology, plasma physics, electromagnetism, and early computational modeling. At the heart of the system was a powerful electromagnetic emitter. Engineers theorized that by directing controlled bursts of energy into specific regions of the atmosphere, they could subtly alter ionized particles in the air. These alterations, while small, were believed to cascade downward, affecting jet streams, cloud formation, and eventually surface weather patterns hundreds of kilometers away. The experiments began cautiously. Early tests focused on localized effects, dispersing fog around airfields, weakening storm systems before they reached strategic sites, or inducing rainfall in agricultural regions suffering from poor harvests. Some internal reports suggested partial success. Fog reportedly thinned faster than expected. Rainfall appeared where models predicted none, but results were inconsistent, difficult to reproduce, and highly sensitive to initial conditions. As the program expanded, so did its ambitions. Planners began to consider military applications. Could a prolonged period of rain slow enemy logistics? Could cold fronts be intensified to strain infrastructure? Could storms be redirected away from Soviet territory and toward adversarial regions? These questions drove funding forward, even as scientific certainty lagged behind. Researchers working on the project described an atmosphere of intense pressure. Failures were rarely documented openly. Successes, however minor, were amplified in internal communications. The system grew more powerful with each iteration, consuming vast amounts of energy and requiring precise synchronization between multiple emitter stations. Yet the atmosphere proved less cooperative than expected. Small disturbances sometimes produced unpredictable results. In one notable test, an energy pulse intended to destabilize a low-pressure system instead appeared to strengthen it, resulting in severe weather well outside the projected zone. Official records downplayed such incidents, but among scientists, concern quietly spread. By the late 1970s, the project faced mounting challenges. Advances in climate science revealed just how complex atmospheric systems truly were. Weather was not a machine with accessible controls, but a dynamic network of feedback loops operating across scales of space and time. The idea of precise manipulation began to feel increasingly unrealistic. At the same time, international attention turned toward the ethics of environmental modification. Treaties emerged restricting the use of weather as a weapon, framing atmospheric interference as a threat to global stability. Publicly, the Soviet Union endorsed these agreements. Privately, funding for the generator quietly diminished. The facility did not close overnight. Experiments continued at a reduced scale, gradually shifting toward purely observational research. By the final years of the Soviet Union, the weather control generator was largely dormant, its towering antennas standing silent against the open sky. Today, the site remains largely abandoned. Rust creeps along metal frames. Control rooms sit frozen in time, filled with analog instruments and handwritten charts tracking winds that have long since passed. No definitive proof has ever emerged that the generator achieved its grandest goals. Yet declassified fragments suggest that, for a brief moment in history, humanity genuinely believed it could negotiate with the weather. As the wind moves freely across the empty steppe, it carries a quiet reminder. Nature listens, but it does not obey. And some forces, no matter how carefully studied, resist being commanded. The Nazi Tachyon communication device. In the final years of the Third Reich, as conventional technologies reached their physical limits, German researchers began to explore ideas that existed far beyond accepted science. Radar had reshaped warfare. Radio waves crossed continents. Encryption had become a battlefield of its own. Yet within a small circle of physicists and military theorists, a more radical question began to surface. What if communication did not need to obey time itself? This question formed the conceptual foundation of what later rumors would call the Nazi Tachyon communication device. The term tachyon referred to a hypothetical particle proposed in theoretical physics, one that could move faster than light, potentially carrying information backward through time. While mainstream science treated the concept cautiously, Nazi research culture encouraged speculative exploration, especially if it promised strategic superiority. The device was not designed as a weapon, but as a communicator, a system that could transmit signals instantaneously, regardless of distance, and, in its most ambitious interpretation, across temporal boundaries. If successful, it would eliminate delays, intercepts, and even uncertainty itself. Orders could arrive before battles began. Intelligence could be received before events unfolded. The research reportedly took place within a compartmentalized program tied loosely to SS-funded scientific initiatives. These programs often blended real physics with ideological mysticism, creating an environment where untested ideas were pursued aggressively. The Tachyon device was said to involve high-energy electromagnetic fields, rotating superconductive components, and resonance chambers designed to amplify exotic particle behavior. Unlike radio communication, which relied on oscillating electromagnetic waves, this system aimed to generate a stable field condition where information could be encoded into fluctuations beyond conventional spacetime constraints. Engineers believed that under extreme conditions, high energy density, precise geometry, and synchronized rotation, space itself could behave differently, allowing information to bypass causal limits. Early experiments reportedly produced ambiguous results. Instruments detected anomalous readings, signals that appeared before their source pulses were fully generated. Data logs showed time offsets too small to measure accurately, yet persistent enough to trouble researchers. Some scientists dismissed these as equipment errors. Others believed they were glimpses of something unprecedented. As the war intensified, pressure mounted. The regime demanded results, not theories. Communication breakdowns, disrupted supply lines, and Allied interception of encrypted messages made secure coordination increasingly difficult. A device capable of undetectable or instantaneous messaging became more than a curiosity. It became a necessity. Yet the deeper the research went, the stranger its implications became. If signals could arrive before being sent, causality itself was threatened. Engineers began encountering paradoxical data loops, messages referencing conditions that had not yet occurred. Whether these were experimental artifacts or genuine anomalies remains unclear, as most records were destroyed or scattered in the final collapse of Nazi infrastructure. Some accounts suggest the project was never completed. Others claim a prototype existed but was unstable, capable only of producing brief, incoherent transmissions. There are even unverified reports that certain late-war German decisions appeared oddly pre-informed, though historians attribute this to coincidence or intelligence leaks rather than time-defying technology. When Allied forces advanced, research facilities were systematically evacuated or dismantled. Equipment vanished. Scientists disappeared into post-war programs or anonymity. Any physical trace of the Tachyon communication device faded into classified archives and rumor. In the decades that followed, fragments of the story resurfaced through declassified documents, second-hand testimonies, and speculative analysis. No definitive evidence has ever confirmed that tachyons were detected, let alone controlled. Modern physics still treats faster-than-light communication as theoretically problematic, constrained by causality and relativity. Yet the idea persists not because it was proven, but because it reflects a moment in history when desperation met imagination. When technology was pushed not just forward, but sideways, into realms where time itself became a variable to challenge. The silence surrounding the project may be its most telling legacy. Not a triumph, not a failure, but an unanswered question. A reminder that some ideas are pursued not because they are possible, but because the fear of not pursuing them feels greater. And somewhere between theory and myth, the Nazi Tachyon communication device remains suspended, forever transmitting, perhaps, but never fully received. The ancient Persian light system. Long before electricity was named, measured, or understood, ancient civilizations were already experimenting with light in ways that still unsettle modern historians. Among them, the Persian world stands apart, not for myth but for its quiet, methodical engineering. Scattered across the ruins of ancient Persia are architectural details that suggest illumination systems far more sophisticated than simple fire or reflected sunlight. The Persian light system, as it has come to be known, was not a single device, but an integrated method of producing and distributing light within enclosed spaces, temples, palaces, underground chambers, without visible smoke, soot, or open flame. This alone challenges conventional assumptions about ancient technology, especially in regions where ventilation was limited and fire would have been dangerous. Archaeological evidence points to the Achaemenid period, when Persian engineers were renowned for their mastery of water management, underground construction, and material science. Kanets, vast subterranean water channels, demonstrate a level of precision that required deep understanding of geology and airflow. It is within these same architectural traditions that the lighting system appears to emerge. Wall surfaces in certain ruins show unusual mineral coatings that reflect light with remarkable efficiency. These were not decorative. Chemical analysis suggests polished limestone mixed with trace crystalline structures capable of diffusing light evenly across large surfaces. In some chambers, the geometry alone would allow even minimal light sources to illuminate entire rooms without direct exposure. More intriguing are the sealed niches found high on walls and ceilings. These cavities show no burn marks, no residue from oil lamps or torches. Yet the rooms they occupy would have been unusable without illumination. This suggests a contained light source, isolated, protected, and possibly non-combustive. Some researchers propose that the Persians may have used early electrochemical reactions, drawing comparisons to the so-called Baghdad battery. While controversial, these clay vessels with metal inserts demonstrate that basic electrical principles may have been known in the region centuries before their rediscovery. If such cells were connected in series, even low voltage could produce sustained luminescence when applied to certain materials. Another theory centers on phosphorescent minerals. Persia was rich in naturally glowing stones, particularly those that emit light after prolonged exposure to sunlight. When embedded into architectural features and charged during the day, these materials could provide soft, persistent illumination at night, silent, smokeless, and stable. The system's purpose was not merely practical. Light held symbolic weight in Persian cosmology. Zoroastrian traditions placed immense importance on illumination as a representation of order, truth, and cosmic balance. Controlled, ever-present light within sacred spaces reinforced this worldview, transforming architecture into a living expression of philosophy. Over time, as empires fell and religious practices shifted, the knowledge behind the system faded. Later civilizations reused Persian structures without understanding their original function. Niches were sealed, coatings eroded. What remained appeared ornamental, stripped of its technological context. By the medieval period, open flame became the default explanation for all ancient lighting. The absence of soot was ignored or explained away. The idea that an ancient civilization could illuminate space without fire did not fit prevailing historical narratives. Modern rediscovery of these sites reignited the debate. Engineers, not historians, were often the first to question how such spaces functioned. Simulations showed that conventional lamps would have failed. Ventilation patterns did not support sustained burning. Something else had been at work. Whether the Persian light system relied on chemistry, mineral physics, electrostatic effects, or a combination of all three remains unresolved. What is clear is that the knowledge was systematic, repeatable, and intentionally concealed within architecture itself. It was not erased through violence or prohibition, but through neglect. A technology that required continuity to survive, lost when the cultural framework supporting it disappeared. Today, the ruins remain quiet. Sunlight still touches the same stones. And in certain chambers, even now, the walls seem to hold light longer than they should, as if remembering a time when illumination did not come from fire, but from understanding. The Soviet mind-machine interface. During the height of the Cold War, the Soviet Union invested heavily in technologies that blurred the boundary between human cognition and mechanical systems. While the West focused on computing power and automation, Soviet research followed a parallel path, one less visible, more introspective, and far more experimental. At the center of this effort emerged what later became known as the Soviet mind-machine interface. The origins of the project can be traced to post-war neurophysiology. Soviet scientists had long rejected the idea that the mind was an abstract phenomenon. Instead, it was viewed as a measurable physical process, electrical, chemical, and rhythmic. Brainwaves were not symbolic expressions of thought. They were signals no different in principle from radio transmissions or control voltages. Early experiments focused on electroencephalography, measuring neural oscillations under controlled conditions. Researchers noticed consistent patterns associated with focus, fatigue, fear, and decision-making. These patterns proved stable enough to be quantified, replicated, and, most importantly, predicted. The implications were immediate. If mental states could be detected, they could potentially be guided, reinforced, or overridden. By the 1960s, the research expanded beyond observation. Soviet laboratories began developing systems that allowed machines to respond directly to neural activity. Crude by modern standards, these interfaces used electrode arrays placed on the scalp, translating brain signals into mechanical outputs. Simple tasks, switch activation, signal modulation, directional control, were achieved without physical movement. What distinguished the Soviet approach was its intent. The goal was not convenience or accessibility. It was control. Military planners envisioned pilots operating aircraft systems under extreme stress without manual input. Operators could guide drones, missiles, or surveillance equipment while remaining physically stationary. Reaction time would be reduced to thought itself. As prototypes evolved, feedback systems were introduced. Machines no longer merely responded to the brain, they influenced it. Electromagnetic pulses, synchronized frequencies, and rhythmic stimulation were applied to reinforce specific neural patterns. Focus could be sharpened, fatigue delayed, emotional response flattened. This feedback loop became the core of the mind-machine interface. Human and system entered a closed circuit. The operator was no longer fully separate from the machine, and the machine was no longer passive. Performance improved, but so did instability. Subjects reported dissociation, time distortion, and a diminished sense of agency. By the late Cold War period, classified documents suggest the interface was tested in prolonged sessions. Cognitive endurance increased, but psychological side effects accumulated. Some participants experienced lingering neural echo, unintentional activation of system-linked brain states long after sessions ended. The boundary between voluntary thought and conditioned response began to erode. The program remained compartmentalized. Civilian scientists were rarely informed of military applications, and military personnel were discouraged from asking about the underlying science. This isolation slowed refinement but prevented broader ethical scrutiny. Officially, the research was framed as advanced ergonomics and human factors engineering. As computing technology advanced, Western brain, computer interfaces shifted toward digital signal processing and AI interpretation. The Soviet model remained analog, frequency-based, and deeply biological. It required constant calibration and human vulnerability. It worked, but at a cost. With the dissolution of the Soviet Union, funding vanished almost overnight. Laboratories were abandoned. Equipment was dismantled or sold. Data archives fragmented. Many researchers transitioned into civilian neuroscience, while others disappeared from public records entirely. What survived were fragments, schematics without context, anecdotal reports, and a handful of declassified references confirming that direct neural-machine coupling had been achieved decades earlier than widely acknowledged. The system was never formally banned, but it was quietly discontinued. Modern interfaces prioritize user autonomy and safety, distancing themselves from direct neural feedback manipulation. Yet the foundational ideas remain. Thought as signal, mind as interface, control without movement. The Soviet mind-machine interface did not vanish because it failed. It vanished because it worked too directly, too intimately. It demanded a level of surrender from the human operator that history was not ready to accept. And in the silence left behind, the question it raised still lingers, not how machines can think like humans, but how easily humans can be shaped to think like machines. The Nazi plasma containment ring. As the Second World War entered its most desperate phase, German scientific research began shifting away from conventional engineering toward experimental physics at the very edge of understanding. Fuel shortages, material constraints, and escalating Allied pressure forced German planners to search for radically new energy sources. Within this environment emerged one of the most obscure and controversial projects of the era, the Nazi plasma containment ring. The concept originated from early plasma physics, a field still in its infancy during the 1930s and 1940s. Plasma, often described as the fourth state of matter, fascinated German physicists due to its immense energy potential and unusual electromagnetic behavior. Unlike solids, liquids, or gases, plasma could conduct electricity, generate magnetic fields, and respond dynamically to external forces. In theory, controlling it meant accessing extraordinary power. German researchers believed plasma could be stabilized and confined using precise electromagnetic geometries. Rather than relying on linear magnetic fields, they experimented with closed-loop configurations, rings designed to trap plasma in continuous motion. These structures were intended to create self-sustaining energy cycles, minimizing losses and maximizing field coherence. The plasma containment ring was reportedly constructed from layered conductive alloys arranged in toroidal form. High-voltage inputs ionized gases within the ring, creating a circulating plasma stream. Magnetic coils embedded in the structure generated counter-rotating fields, preventing the plasma from dispersing or collapsing. The design bore conceptual similarities to later fusion research, though decades ahead of its time. The intended applications were multiple. At its core, the device was envisioned as a compact energy source, one that could operate independently of traditional fuel. Military planners speculated that such a system could power advanced propulsion platforms, directed energy weapons, or electromagnetic shielding systems. None of these applications were realized in full, but they shaped the direction of research. Initial tests reportedly achieved brief plasma stability. Observers noted intense luminosity, electromagnetic interference, and anomalous thermal effects. Instruments recorded energy outputs inconsistent with input levels, though measurements were unreliable under wartime conditions. These anomalies fueled both excitement and concern among the research teams. Stability proved elusive. Plasma containment required constant calibration, and even minor field irregularities caused rapid destabilization. In several instances, containment failures resulted in violent discharges, damaging equipment and injuring personnel. These incidents reinforced the perception that the technology was both powerful and dangerously unpredictable. Complicating matters further was the theoretical ambiguity. Plasma behavior was poorly understood, and mathematical models were insufficient to fully describe the observed phenomena. Engineers relied heavily on empirical adjustments rather than predictive control. Progress was slow, fragmented, and increasingly secretive. As Allied forces advanced, the project faced abrupt termination. Facilities associated with advanced plasma research were either dismantled or destroyed. Surviving components were reportedly seized and transferred into post-war intelligence programs, where they vanished into classified research pipelines. Post-war analysis by Allied scientists found no complete documentation of the plasma containment ring. What remained were partial schematics, test logs without conclusions, and testimonies lacking technical detail. The absence of a finished device suggested the project never reached operational maturity. Yet its conceptual legacy endured. Decades later, plasma confinement became central to fusion research, space propulsion studies, and advanced materials science. The toroidal configurations explored by German researchers echoed in modern tokamak designs, though developed independently and under entirely different ethical frameworks. The Nazi plasma containment ring stands as an example of technology pursued under extreme pressure, where ambition outpaced understanding. It was neither a myth nor a breakthrough, but a transitional experiment, one that hinted at future possibilities without possessing the tools to realize them. Its erasure from history was not the result of suppression alone, but of incompletion. A system too unstable to deploy, too dangerous to continue, and too advanced to fit the technological landscape of its time. In the end, the ring did not contain plasma for long, but it briefly contained an idea that energy itself could be shaped, trapped, and bent to human intent. An idea that would resurface decades later, stripped of ideology, but carrying the same underlying promise. The ancient Celtic energy stones. Across the landscapes of ancient Europe, long before written records could preserve intent, the Celts left behind a network of stone structures whose purpose remains only partially understood. Stone circles, standing monoliths, and carefully aligned formations appear across Ireland, Britain, and continental Europe. While often classified as ritualistic or symbolic, a closer examination suggests these structures were part of a systematic interaction with natural energy phenomena. This system has come to be referred to as the ancient Celtic energy stones. The Celts were not centralized builders, yet their stone constructions share remarkable consistency. Sites separated by vast distances exhibit similar dimensions, orientations, and material choices. This uniformity implies a shared technical tradition, transmitted orally and refined over generations. The stones themselves were selected deliberately, often composed of granite, basalt, or other igneous rock rich in quartz and magnetite, materials known today for their piezoelectric and electromagnetic properties. Placement was critical. Many of these structures are located along geological fault lines, underground water channels, or areas of heightened geomagnetic activity. Modern measurements reveal subtle but measurable electromagnetic fluctuations at these sites. While naturally occurring, their concentration around Celtic stone formations suggests intentional alignment rather than coincidence. The stones were erected vertically, maximizing interaction with the Earth's electromagnetic field. Their height, mass, and spacing created resonant configurations capable of amplifying ambient energy. When subjected to environmental stimuli, wind, seismic microvibrations, or human contact, quartz-bearing stones could generate small electrical charges. Individually insignificant, these charges became coherent when organized within a structured array. Archaeological, where patterns indicate repeated human interaction. Grooves, polished surfaces, and footpaths suggest these sites were not passive monuments. They were activated through movement, sound, and presence. Vocalization within stone circles produces measurable acoustic resonance, reinforcing the idea that sound played a functional role. Low-frequency vibrations could induce mechanical stress within the stones, enhancing piezoelectric effects. This interaction between sound, stone, and earth formed the core of the energy system. The Celts did not extract energy in the modern sense. They modulated it. The stones acted as stabilizers, synchronizing human activity with natural electromagnetic rhythms. This synchronization likely produced altered states of perception, heightened awareness, clarity, or physiological calm. The purpose of the system appears practical rather than mystical. Many stone sites coincide with seasonal markers, agricultural cycles, and navigational alignments. The energy stone network may have served as a distributed environmental interface, helping communities maintain temporal and spatial coherence without written instruments. Over time, as Roman influence spread and centralized structures replaced local systems, the knowledge supporting these stones eroded. The engineering logic was preserved only as tradition, then as ritual, and finally as folklore. Without maintenance or understanding, the functional framework collapsed. Later cultures repurposed the sites symbolically. The original interactions were simplified into ceremonies, detached from their technical origins. Stone circles became sacred without explanation. Energy became myth. Utility dissolved into reverence. By the medieval period, the system was functionally dead. Stones remained, but their role as active components in a broader network was forgotten. Attempts to dismantle or relocate them often failed due to their mass and placement, inadvertently preserving the structures through neglect rather than protection. Modern scientific analysis has reintroduced a different perspective. Studies of geomagnetism, acoustic resonance, and piezoelectricity reveal that the Celts may have intuitively exploited natural physics without formal theory. Their technology was not mechanical but environmental, not powered but tuned. The ancient Celtic energy stones were not erased by force. They were overwritten by time, a technology dependent on continuity, participation, and subtle interaction could not survive in a world that favored documentation and centralized control. What remains today is stone, silent, immobile, and patient. Yet beneath that stillness lies a system once capable of aligning human activity with the invisible forces of the earth. A system that required no engines, no wires, and no fuel. Only understanding. The American Gravity Nullification Project. In the decades following the Second World War, the United States emerged not only as a military superpower, but as a laboratory for radical theoretical research. Victory had proven that unconventional science could change the course of history, and American defense institutions became willing to explore ideas once considered implausible. Among the most secretive of these initiatives was what later became known as the American Gravity Nullification Project. The project did not begin with anti-gravity fantasies, but with a practical military problem. Conventional propulsion systems imposed limits on speed, maneuverability, and payload. Aircraft and missiles were constrained by fuel, structural stress, and inertia. Engineers sought a method to reduce mass effects without altering physical weight, a distinction that would redefine motion itself. Gravity, long treated as an immutable force, became the focus. American physicists revisited earlier theoretical work on inertial mass, spacetime curvature, and field interactions. The emerging question was not how to escape gravity entirely, but how to decouple objects from its influence under controlled conditions. Research accelerated during the early Cold War, when reports of unconventional Soviet and German wartime experiments began circulating through intelligence channels. Whether these reports were accurate mattered less than their psychological impact. The possibility that an adversary might manipulate gravity compelled American agencies to investigate the concept themselves. The Gravity Nullification Project was housed within a network of classified research facilities, often disguised as conventional aerospace or materials laboratories. Its core hypothesis proposed that gravity was not merely a force acting on objects, but an emergent effect tied to electromagnetic and quantum fields. If these fields could be altered locally, gravitational interaction might be weakened or redirected. Early experiments focused on high-energy electromagnetic configurations. Rotating superconductive masses, rapidly oscillating fields, and precisely timed electrical pulses were tested to observe minute changes in weight and inertia. Measurements were subtle, often bordering on the limits of instrumentation accuracy. Yet anomalies appeared consistently enough to sustain funding. Engineers reported transient reductions in effective mass during peak field synchronization. Objects subjected to these conditions required less force to accelerate and exhibited delayed inertial response. While gravity itself was not eliminated, its practical effects appeared diminished for brief intervals. These results attracted military interest. A platform capable of reducing inertial load could achieve unprecedented acceleration without structural failure. Aircraft could maneuver beyond pilot tolerance limits. Launch systems could operate with lower energy costs. The strategic implications were profound. As the project advanced, containment and stability became central challenges. The field configurations required extreme precision. Minor phase mismatches caused rapid system collapse, accompanied by intense electromagnetic discharge. Safety incidents were rarely documented, but the program's compartmentalization suggests repeated failures. By the late 1960s, the project reached its theoretical peak. Computational modeling improved prediction accuracy, yet scalability remained elusive. Effects were localized, short-lived, and energy-intensive. Achieving sustained gravity nullification would have required power sources beyond what was feasible at the time. Despite these limitations, the project did not end abruptly. Instead, it fragmented. Elements were absorbed into aerospace research, material science, and advanced propulsion studies. Officially, gravity nullification was never acknowledged as achievable. Publicly, the concept was dismissed as speculative or fringe. Internally, however, the data was preserved, not as proof of success, but as evidence that gravity could be influenced indirectly through field interaction. The project shifted from applied engineering to theoretical groundwork, awaiting future technologies capable of sustaining such conditions. As funding priorities changed and geopolitical tensions evolved, the original program faded into obscurity. Documents were reclassified, renamed, or buried within unrelated initiatives. No single report marked its conclusion. The American Gravity Nullification Project was not erased because it failed, nor because it succeeded. It was erased because it occupied an uncomfortable space between possibility and practicality. Too real to ignore, too incomplete to deploy. Today, gravity remains officially untouchable. Yet modern research into spacetime manipulation, inertial dampening, and field-based propulsion echoes the same questions asked decades earlier. The project's legacy survives not in machines, but in the frameworks used to imagine them. It stands as a reminder that some technologies are not forbidden by law or ethics, but by timing. Ideas that arrive before the world is ready do not disappear. They wait, classified, dormant, and unfinished. The lost invention of Viktor Grebennikov. In the late 20th century, far from military laboratories and state-funded research centers, a quiet discovery emerged from an unexpected place. Viktor Stepanovich Grebennikov was not a weapons engineer or defense contractor. He was an entomologist, a biologist whose life was devoted to the study of insects. Yet his observations would lead him toward a phenomenon that challenged conventional physics and eventually faded into obscurity as one of the most enigmatic lost inventions of modern history. Grebennikov's work began with close, methodical observation of insect behavior and structure. While studying the microscopic anatomy of beetles and wasps, he became fascinated by the geometric precision of their exoskeletons. Under magnification, certain chitinous structures revealed complex lattice patterns, repeating cavities arranged with remarkable uniformity. These were not decorative features. They appeared optimized, as if shaped by a functional requirement beyond biology alone. During prolonged study, Grebennikov noticed something unusual. When certain insect shells were placed near one another in specific orientations, his instruments registered anomalies. Mechanical balances behaved unpredictably. Fine particles shifted without apparent force. Even biological responses, such as dizziness and spatial disorientation, were reported during extended exposure. Grebennikov concluded that these structures interacted with what he called cavity structural effects. According to his observations, the precise geometry of microscopic cavities could influence surrounding physical fields. This interaction did not rely on heat, electricity, or magnetism as traditionally understood. It was passive, structural, and persistent. Over time, he attempted to replicate the effect artificially. Using layered plates with cavity patterns modeled after insect exoskeletons, Grebennikov assembled a platform capable of amplifying the phenomenon. When stacked and aligned correctly, the plates produced effects that were impossible to explain using known physics. Weight reduction, altered inertia, and spatial distortion were reported. The most controversial result was mobility. Grebennikov claimed the platform could lift and move without conventional propulsion. There were no engines, no exhaust, no rotating parts. The device responded only to orientation and balance, as if interacting with an unseen field embedded in space itself. Unlike classified military projects, Grebennikov documented his findings openly. He published diagrams, descriptions, and theoretical interpretations. His tone was observational, not promotional. He made no attempt to weaponize or commercialize the invention. This openness, paradoxically, may have contributed to its disappearance. The scientific community reacted with skepticism. The effects were difficult to reproduce without exact structural precision. No established theoretical framework could account for them. Without institutional backing or reproducible laboratory confirmation, The invention was dismissed as misinterpretation or experimental error. Yet dismissal did not equal refutation. Grebenikov's work existed in a gray zone, too detailed to ignore entirely, too unconventional to accept. As interest waned, so did opportunities to refine or validate the technology. After his death, the original device vanished. The remaining materials were incomplete, and attempts at reconstruction failed to replicate the reported effects. What made the invention uniquely fragile was its dependence on geometry rather than power. There were no adjustable parameters, no digital controls, no measurable outputs to optimize. The system either worked or it did not, and success depended on microscopic accuracy that few could achieve. Over time, the invention was absorbed into folklore rather than science. References became fragmented. Translations distorted original terminology. The absence of physical evidence allowed the story to drift toward speculation, overshadowing the careful observations that initiated it. The lost invention of Viktor Grebennikov was not erased by secrecy or prohibition. It faded because it existed outside established categories. It was not mechanical enough for engineers, not theoretical enough for physicists, and not biological enough for biologists. Its disappearance highlights a different kind of technological vulnerability. Some inventions do not require suppression to vanish. They require only neglect, disbelief, and the absence of a framework willing to accommodate them. What remains is a record of quiet persistence. A scientist observing insects, following patterns without assumption, and arriving at a conclusion that could not survive without continuity. The device is gone, but the question it raised remains unresolved. Whether the effect was misunderstood or prematurely abandoned may never be known. But its loss serves as a reminder that history does not erase only dangerous ideas. It also erases those that arrive without a place to belong. Ending. As this journey comes to a close, what remains is not a list of machines or forgotten names, but a pattern that repeats itself across centuries. Again and again, ideas appear that do not fit their time. Some are too subtle, some too unstable, some too uncomfortable to be understood or preserved. They fade not because they are proven false, but because the world moves on without them. These inventions, real, speculative, or suspended somewhere in between, share a common fate. Their traces survive only in fragments, testimonies, and unanswered questions. History does not always erase through destruction. Often, it erases through silence. If you found this exploration intriguing, take a moment to support the channel. A like helps these stories reach others who enjoy slow, thoughtful journeys into the forgotten edges of science and history. Subscribe if you want to continue exploring ideas that time chose not to keep. Leave a comment and share your thoughts, whether you see these inventions as lost breakthroughs, misunderstood experiments, or reflections of human curiosity itself. And if you know someone who enjoys falling asleep to quiet stories of hidden knowledge, share this video with them. Thank you for listening. Good luck and sweet dreams.